Okay, good morning, everyone. I'd like to continue where we left off. I was on page 6. The last problem that we did was this Julian Chan problem, right? Do you have any questions on anything I've done? If not, I move on. So today we want to cover dollar-weighted yields and time-weighted yields. So I'm on page 6. I'd actually like to write. So you might want to do the same. So let me say here, wait, this is kind of wrong. Hang on one second, guys. Okay, so regarding page 6, dollar-weighted yield rates. So we're trying to approximate, approximate dollar-weighted yield rates. I will do the exact dollar-weighted yield rate also later. So let t equals 0 be the time of the initial investment. Let t equal 1 be the time of the last investment. Even if it is 3 years from now. And by the last investment, I don't mean the last contribution. I mean all the way at the end. Let A be the total funds invested at time 0. Let B be the total funds at t equals 1. So we are rescaling the time. Let's say something occurs over 15 years. I'm going to call 0, 0, and 15, 1. Follow me? So we're rescaling. Rescale, in other words. CT is the fund contribution at time t. Positive for investing and negative for withdrawal. So by investing I mean deposit, and negative for withdrawal as usual. Let C be summation CT. Let I be the interest earned on A, which is the initial investment, and CT, meaning all the contributions. Then B equals A plus C plus I. So I'm saying that the total funds at t equals 1 is going to be what you started with plus what you contributed plus the interest earned on both of those. Agree? Therefore, I is equal to B minus A minus C. So A of 1 minus A of 0 is equal to the interest, where A is the amount function. The interest earned on A, where A is the initial investment, is equal to A times 1 plus J minus A. So this A cancels with this A. One is positive, one is minus. So I'm left with A times J. That's the interest on the initial amount A. The interest on the contributions is equal to summation CT, that's the contribution, the contribution at time t, times 1 plus j to the 1 minus t minus CT. Let me explain. So you have time 0, you have time t, a contribution was made at time t of CT, and here's time equals 1. So this time right here that this contribution grows for 1 minus t, because we've rescaled, right? So the end of the investment period that we're talking about here has been rescaled to 1. Therefore, if a contribution is made at time t, that contribution will grow for 1 minus t. In other words, if it's made at time 1/3, it will grow for 2/3 of the period. That's what I'm saying. So, let's say 1 minus t is the part of the year that is left during which this contribution grows. Therefore, this follows. So you have CT, 1 plus the yield to the 1 minus t. This is the period that's left for it to grow, minus the original. So I'm going like this. The whole thing is under the summation. Are you following me? Okay. So the total interest I is equal to A times J from here plus summation CT 1 plus J to the 1 minus T minus 1. Let's pull out this CT like this. And this is really hard to solve. The unknown is J. I'm looking for J. Looking for J. And this is hard to solve. So, instead, let us assume simple interest. For this. Instead of compound interest, I'm assuming that it's simple interest. In other words, I'm going to do the binomial expansion for 1 plus j to the 1 minus t. Yeah.
Is that A times j or A of j?
A times j. So let me back up and explain that, okay, so that it's clear. When you start with $, I'm saying that $, will turn to A times 1 plus I and I'm calling my ij here, right? So I'm saying at the end of the period 1, it's just a times 1 plus I to the first power, right? That's what this is, minus what you started with. When I take this difference between what you end up with and what you started with, it will give you exactly the interest that you earned on A. So that's A times J, this like so. Okay, so instead let us take, assuming simple interest, the binomial expansion. So 1 plus j to the 1 minus t times ct will be equal to ct times j 1 minus t. So let me back up here. You know how we say that in simple interest, if you start with $, at the end I will have A1 plus I times T, the amount of time that the thing was invested. That's what I'm doing here. I'm starting with CT. So I should probably have a 1 plus here, times 1 plus, this is the time that it's going to be invested, and this is the interest rate. Does that make sense? This is the simple interest. Accumulation function. Right here. 1 plus I times the amount of time that the investment is in, right? 1 plus IT. That's what this is. Only my I is being called J, and the amount of time that it is in there is 1 minus T, because it only exists from time T to time 1. So that period is 1 minus T. Okay, so let me continue. Total I is equal to A times J plus summation CT times 1 plus J, 1 minus T. Pull the J out. Give me 1 second. CT, 1 plus J, 1 minus T. And I want only the interest part, because I'm talking about only interest here. So minus CT. So this CT right here and this CT will be gone, because I'm only interested in CT times the interest part, which is I times the period that it was invested. Does that make sense? So this is AJ plus summation. Let's pull the J out of the summation, because J is not in there. So pull this J out, and then you have CT 1 minus T. And then let me factor out the J. J, A plus summation CT 1 minus T equals I. So I'm interested in the yield rate. Let's continue this on the next page. So the yield rate J is equal to the interest divided by, I'm solving for J here. So continuing here, I'm just solving for J. J equals I divided by A plus summation CT times 1 minus T. And this J is going to be called J dollar weighted. DW for dollar weighted. So look at the denominator as the average amount invested during the entire period. And of course the period was rescaled from 0 to 1. So JDW is a many year return. We want the I dollar weighted, which is the annual rate. So I'm going to say 1 plus I dollar weighted to the N equals 1 plus J dollar weighted. Therefore, 1 plus I dollar weighted is equal to 1 plus J dollar weighted to the 1 over N power, and I dollar weighted is equal to 1 plus J dollar weighted to the 1 over N power minus 1. Where I is the annual dollar weighted yield. Annual dollar weighted yield. Have I managed to confuse anyone? Do you want me to start over and explain again? Or do you understand? Which? Does anybody need further explanation? I'll be happy to explain. Look, there are two things going on here, right? You're starting with A dollars at time 0. So that A dollars at time 0 grows to A parentheses 1 plus interest raised to some power, right? Now we have rescaled the time. So that A has pretty much, once the rescaling has been done, that A grows to A parentheses 1 plus J to the first power, because your time frame is 1 year, because you have rescaled, right? So if the total A times 1 plus J, if this is the total at the end of the period, and if you started with A, then the amount of interest on that A is A times J, because I took the difference between what you ended up with and what you started with. Finished. Then there's contributions that came in throughout the period. So maybe you started with $1 million, and then at time 1, 100,000 was deposited, and then at time 2, 50,000 was taken out, and at time 3, another 100,000 was deposited, and so forth. Now we have rescaled the time. So if the contribution comes in at time t, then 1 minus t is the period left within that time frame during which that contribution gets to grow, right? So the period during which it gets to grow is 1 minus t, and I would raise my 1 plus I. My interest rate is J in this case, right? So every time I say I, in this case it's J dollar weighted. So 1 plus J will get raised to that period, 1 minus t. So here's the initial contribution. Here's the contribution grown, and then I'm subtracting away the contribution to see what the growth was, the interest that was made on that contribution. So here I'm saying that the total interest is equal to the interest on A, which is AJ, plus the contribution, grow it at simple interest, because this is harder to work with. We're assuming simple interest. So 1 plus I times the time that it grows. That's the accumulation function for simple interest, minus what you started with. So basically it's just C times J times 1 minus T. pull out the j, and solve for j. So you have total interest divided by a plus summation ct 1 minus t, which is what you see here. Now, once you get this number, j dollar weighted is going to be a many-year return. So I have to annualize that. So how do you annualize? You take 1 plus I, which I'm looking for, raise it to the nth power, because this goes on for n years. Remember, we scaled from 0 to n onto 0, 1. But really, this went on for n years. So 1 plus I dollar weighted to the n equals 1 plus j dollar weighted, where j dollar weighted is the many-year return. And then you solve. Get it? Okay. Let's do an example. How about the first example on page 7? An investment manager has a fund of $100,000 at the start of the year 2006. So I could write A equals 100,000. On June 30th, the value of the fund is 90,000, but a new deposit of 110,000 is made. At the end, at year end, the account balance is 220,000. Okay, so this is a really simplified example because N is not a many-year return. N is just 1 year because it's saying at year end you have 220,000. So the typical example will not be so simple. Okay, this is easy. Let's just go through this and then we'll do a tougher one. So it's saying that B, which is your ending balance, is 220,000. And C, which is this total of all the contributions, CT, here I only have one contribution, so there's nothing to add, is equal to 110,000. Measure the return using J dollar weighted average. So it's just a plug-in. First you find I equals B minus A minus C. So it's saying your ending balance minus what you began with minus all the contributions. So plug in 220,000 minus 100,000 minus 110,000. So I is equal to 10,000. And then the next step is just J dollar weighted equals I over A plus summation CT 1 minus T. So this is equal to 10,000 divided by A is 100,000 plus 110 times 1 minus T. Now, at what time did this 110,000 contribution happen? On June 30th, which is exactly half a year. So if the contribution happened at half a year, it still has to grow for a half a year, right? So what I'm saying here is this 110 contribution happened at time 1/2. So it grows for 1/2. So 1/2 goes here because 1 minus 1/2 is 1/2. And then you clean this up. So half of 110 is 55, so 155. So 10 divided by 155, what is it? .0645. Any question? Let's do another one. Let's go to number 5 from chapter 2, review problems. Let's see what page is that on. Page 13. This one right here. I need to do part B, dollar weighted yield. I haven't taught you time weighted yet. So it says, Abby invested $24,500 on 1/1/94. On 5/1/95, his balance was $28,212, and he withdrew $10,000. On 12/1/95, his balance was $15,892, and he deposited $8,000. On 1/1/97, his balance was $33,009, and I'm on part B. Find an approximate annual dollar-weighted yield received by Abby for the 3-year period. Okay, so let me draw a timeline. So on 1/1/94, Abby invested $24,500. That's my A. On 5/1/95, his balance was $28,212. I don't care about that. And he withdrew $10,000. So let's write here 5/1/95. He withdrew $10,000. On 12/1/95, his balance was $15,892. I don't care about that for dollar weighted averaging. And he deposited $8,000. So here is 12/1/95, deposited $8,000. On 1/1/97, his balance was $33,009. 1/1/97, $33,009. And that is B. So I have to rescale. So let's call this one time 0. And this is time 1. So time 1 is exactly 36 months later, right? So let's call this 36 over 36. And this one is 16 over 36. And this one is 23 over 36. Because 1/1/96 would have been 24 out of 36. This is 1 month prior. Okay. So my total contribution, C, equals summation, CT, is equal to minus 10,000 plus 8,000, which is minus 2,000. Then I say I is equal to B minus A minus C, which is equal to, my B is 3,309 minus 24,500 minus negative 2,000. So I turns out to be 7,809. Therefore, J dollar weighted is equal to I over A plus summation CT 1 minus T. So 7,809 divided by A, which is 24,500, plus every contribution times the amount of time it is left to grow. So 10,000. Actually, this is a negative, right? This is a minus 10,000. So let's fix that. Minus 10,000, and this time left over would be 36 minus 16, which is 20 over 36. I'm doing 1 minus T. And then the next contribution is positive, plus 8,000. This occurs at time 23 out of 36, so what is left is 13 out of 36. 13 out of 36. So can you please get me a number for J dollar weighted? The denominator consists of all this stuff. What did you get? I got 0.357. Did anyone get that? Okay. So JW 0.357. Now this is a 3-year rate. 3-year rate. I need the annual rate. So I want 1 plus I dollar weighted to the third power equals 1.357. And solve. So you get 1 plus I, 1 plus I equals 1.357 raised to the 1/3 power, which is equal to 1.107. Therefore, I dollar weighted is equal to 0.107. That is the annual dollar weighted yield. I is the annual dollar weighted yield rate. Everybody okay? Yes or no? Okay, now let's find the actual yield rate for this problem. This was an approximation, okay? This is an approximation, I dollar weighted. So let's say find an approximate annual dollar weighted yield rate. Now I want to find the actual dollar weighted yield, which is the same as the internal rate of return. Let's do that. So that was page 13. This is page 13A. So I need my timeline again. Goal is to find the actual dollar weighted yield rate, otherwise known as the internal rate of return. The other one was an approximation. So let's do my timeline. I had 24.5 at 1,194, which is time 0, 24.5. And at 5,195, which was time 16 over 36, negative 10,000 was a contribution. And then at 12,195 time 23 over 36, positive 8,000. And I ended up with 3309 at time 1197, which was 36 over 36, which was time 1. So let me write my equation. 24,500 times 1 plus j to the first power minus 10,000, 1 plus j to however much time is left to grow. So if I am at 16 over 36, this will grow for 20 out of 36, right? Plus $8,000. How long does 8,000 have to grow if you are sitting at 23 out of 36? 13 out of 36 equals 3309. So this is the time what equation of value? What time equation of value is this? Time tau equals 1, equation of value. Can we clean this up? Let's divide by 1,000. And what should we say? X equals 1 plus j. Let x equals 1 plus j and divide by 1,000. I get 24.5 x minus 10 x to the 20 over 36 power plus 8 x to the 13 over 36 minus 30.309 equals 0. Let's put this into our calculator. Let me get my calculator out. So y equals 24.5x minus 10x raised to the 20 over 36 plus 8x raised to the 13 divided by 36 minus 30.309. Let's check the window. So let's see, my x is 1 plus j. So let me go from 0 to 2. This will work, I believe. Let's go to second calc, 0. So left bound 1 sounds good. Right bound, say 1.5. You could have said 2 even. 1.5. Guess 1.5? Sure. Hit enter. So for 0 I get 1.356. Did you? Great. So before I do anything, let me say I'm using the calculator. I did y equals, I put the equation in, and I said left bound equals 1, and right bound equals 1.5, and guess equals 1.5. And I got x, which is really 1 plus j, equals 1.3560206. And that's a 3-year return. So 1 plus I cubed equals 1.3560206. 1 plus I equals 1.3560206 raised to the 1/3 power, which is 1.3560206 raised to the 0.3 repeating. Oops, what happened here? Sorry. 1.3560206 raised to the 0.3 repeating. 1 plus I equals 1.1068499. So I equals 0.10685. That's the actual dollar weighted annual yield. Wait, I dollar weighted, no approximation. And what did we get for the approximate value, which was much quicker to do? What did we get? We got 0.107. Really close. Right? So, if you don't want to do the dollar weighted the way we did before, you could use this exact timeline and just replace all of these by the simple interest approximation right here. So look what I'm trying to say. Perhaps, you know how we said let J dollar weighted be I over A plus CT 1 minus T? If you don't want to use that canned approach, you can just look at this and do the dollar weighted approximation right from here. Let me show you how. Perhaps this would be better for the dollar weighted approximation. Watch what's really happening here. You kind of lose that when you use the A and the B and the I. So could I not say 24,500 times 1 plus j to the 36 over 36 minus 10,000, 1 plus j to the 20 over 36 plus 8,000, 1 plus j to the 13 over 36 equals 30,309. That's what I have up here. That's the actual one, right? Now I'm going to do simple interest approximation. Now, assume simple interest instead of compound. So every 1 plus j to the t will be replaced by 1 plus jt, right? So replace every 1 plus j to the t by 1 plus jt. So this would become 24,500 times 1 plus j times 1, which I don't have to write, minus 10,000, 1 plus 20 over 36j plus 8,000, 1 plus 13 over 36j equals 30,309. And solve. So 24,500 minus 10,000 plus 8,000 plus j times 24,500 minus 10,000 times 20 over 36 plus 8,000 times 13 over 36 equals 3309. Do you see that this what I've done here is the same as solving for j over there, which was j equals b minus a minus c, when I bring these over to the other side, divided by a plus the contribution times the time it's left to grow. It's exactly the same as what we did before, and we don't have to memorize anything if we use this with this timeline above. You follow what I'm doing? So all this business of I divided by a plus sigma summation ct 1 minus t is just exactly this, because this right here is b minus a minus c divided by a plus contribution times the 1 minus t period. Do you see it or no? So this will give you exactly the same answer as what I got before. Let me finish it up, okay? So j equals 30,309 minus, what do I have here? I'll bring each one over. Minus 24,500 plus 10,000 minus 8,000 divided by 24,500 minus 10,000 times 20 over 36 plus 8,000 times 13 over 36, and that will give me 0.35766, which is what I got here on the previous page when I was doing it also, 0.357. So it's exactly the same, and you don't have to memorize anything. You just have to write out your timeline and then replace every 1 plus j to the t by 1 plus jt. and it would give you the same answer. That's exactly what was going on in that previous approximation that we were doing. Are you with me or no? What's your question, guys? So next time, let's do time-weighted yield, which is very simple. And then we'll do lots and lots of examples. Like that?
Yeah.
So if I were to label this, right, just to make it look like the other one, I would say this: B minus A minus C, which is otherwise known as I, over